4 of Chapter 5. The first thing we want to discuss in this lesson is a data class which you can instantiate an object on called array list. And this is very similar to an array, but unlike an array, you don't have to define the length of it. And as probably a lot of you have surmised, the reason I'm doing all this talking about how to store data inside a program is a possible solution to the problem we initially posed when we were first thinking about creating this program. And this initial illustration or diagram of what we wanted to do, we said we wanted to get the names of all the files downloaded into a directory and then insert those names into a text file we have, which lists all the files we've ever downloaded. So for one thing, we know that we're not downloading duplicate files, because when we download, we look at this history every time and check to see whether we've already downloaded it. And then once we've done this insert of the names in this directory into this history file, we want to move all the files, downloaded files, into another directory we're using for backing up. And the reason you definitely have to move them out after you insert them into the history file is if you run the program again, you're going to get duplicate names if you left any in there. So we had to think about how we're going to do that, and there's probably a number of solutions to this problem. If you think enough, there's usually a number of solutions to just about any problems. But one way we could do it is when we start out, we take the history file and we read the whole thing into a data structure or some way of saving data inside the program, some dynamic way in memory, i.e. a variable or an array. And then we also do a listing of the files in the directory and append or add those files to the data structure in memory that we had added the initial list of the history file to. And then we'll have all the names together to do. Well, we'd have to get them in alphabetical order, because if we just appended it, they'd be out of order. But we need to sort them at that point, so that in the memory structure they're all in the correct alphabetical order, and then we'd have to write them out to a file which would then be the new version of the history file. And at that point we've accomplished more or less our goal. Although once we do that, we're probably going to think of some nice bells and whistles we're going to want to add to the program, as will turn up later on in this progressive development. So the data structure we want to put these in is an array list. And we need an array list because we don't know how many names are going to be in the history file, and we don't know how many names of the files are going to be on the directory. So we need something that dynamically expands as you add to it. And array list is the ticket. When you look at the way you define arrays, as we discussed in the last lesson, there's several ways of doing it. Actually, I'm not even showing the way we did it in the program. The way we did it in the program is we initially declared the array, had a semicolon at the end of a statement, and then we allocated the space to the array. So this array, as we're defining it here, could contain 3 items and no more than 3 items, which is the problem we were talking about. We need something that'll dynamically expand as long as we insert things into it. But there's several other ways you can define like a 3-item array, and one of them involves an initializer list. First of all, you could define this all in one line, like this. If I did this, it would essentially do the identical thing. It would declare the array, and then it would allocate the memory for the array, but we could do it all in one line in a statement. And then, as well as that, you can initialize the array. So in this format here, the array is created and initialized all in one move. Between the curly braces is what's known as an initializer list. And once again, we've explicitly said that there's only 3 items. Instead of doing that, you could just put the square brackets without any number and let the initializer list determine how many numbers would be in there. That would be this format here. So we didn't say explicitly that there's only going to be 3 members to this array, but because the initializer list only contains 3 numbers, 100, 95, and 97, the compiler knows that it's going to be a 3-member array and allocates that much memory. And in fact, there's a shorthand way of writing that where you just skip the new int square bracket, and just initially assign the initializer list like this, which the compiler does the same thing. It creates an array of 3 members and initializes it with these 3 values, and that just saves some typing. It's another way of doing it. But in all of these ways of defining an array, they're fixed length, and what we want is something that's variable length. So what we need is the array list class. So what we want to do is instantiate an object called myAL that's of class array list. That's an instance of the class array list. And then we allocate the memory via equals new array list parent. Those are parentheses, not square brackets. And that will basically say myAL is an array list that's allocated an unspecified amount of memory. Every time you add to it, the memory will be there, and we'll just expand the amount of memory you can use in it every time we add to it. So based on what we said, subprogram and the accumulation of the final program that does what we want to do. First thing you'll notice is we've added yet another using. This is for system.collections. And the reason we added that is we want to use the array list we were discussing before, and that class is a part of the system.collections namespace. So the first thing we do is allocate the array list, and then as before we instantiate a stream reader object and open it to the file name that has all our history file in it. And then we have a string variable that's set to null and an index of ix, much the same as before. But now when we do the read line on the stream reader object and assign the first line to input, and we have the while loop where we're checking whether the input's null or not, instead of displaying it on the console, we have this line here which says myal.add input, which is the line we read in. And myal, as you remember, is the array list object. So this is a method of the array list object that adds this string to the array list. It works almost identically to the list box we were looking at early in the course. And then we read in the next line, hit the bottom of the loop, go back to the top of the loop, and if we read in line 2, this won't be equal to null, so we'll fall through and add the second line to the array list, and so on. And then, just for the purposes of this subprogram, we have a for loop that goes through all the array list members and displays them on the screen here. And you notice the thing that terminates the for list is comparing IX to myal.count, and myal.count is a property. .add was a method, and .count is a property, and .count is set to the number of members in the array. So initially IX is set to 0. We go into the loop and it prints out myal square bracket 0 square bracket, which will be the first line that we added to the array list. We hit the bottom of the loop, come back up again. AX is now incremented by 1. So we fall into the loop, and the console.write line prints out myal square bracket 1 square bracket, which is the second line, and so on. We keep looping until IAX is greater than myal.count, which means we've gone through all the members, since .count is set to the number of members in the array list object. And then once we fall through the loop, we do an re.close, which closes our stream reader object. We initially opened with the .openText function of file. Alright, let's see how this runs. We do a directory of the file. We've just our C# program that we've written. We were just looking at file read to array list.cs, and that's such a long name. What I might do is highlight that and then press enter, and in the DOS box what highlighting and pressing enter does, assuming you have it set to do quick edit, is it saves that in the clipboard. And then I'll just do CSC space, which is the C# compiler, and do a right click. And the right click essentially says to take whatever's in the clipboard and paste it into the DOS box at the point the cursor is at. So now if I press enter, it does a compile of that program. And we're done. Now we do a dir, and you see we have both the C# program and a .exe file. And in order to run that .exe file, I'm going to right click again, and this time I want to backspace about 3 backspaces, so we just have the file name and not the .cs, and hit enter. And as you see, it essentially does exactly what the previous program does. It prints out all the lines in that history file. But instead of having them printed out directly from reading them out of the file, we're now storing them in an array list. And then once the array list is filled, that is to say filled because we run out of lines from the history file, we're looping through the array list, and we're actually printing out the array list. We're not directly printing out from the file anymore. So that worked. So we now have another debugged part of the solution to the problem we need to insert into the ultimate program file we're going to use as our final program. Alright, we've discussed array list versus array objects, and we've both written, compiled, and run, or all three of those. The reading the history file into the array list subprogram, which demonstrated the use of the array list class. So those items are all done. The next thing we want to look at is getting a list of file names from a directory. If you look again at our original design proposal, there's two things we need to read into the array list. The first thing is the history of the downloads, and the second thing is the directory file names of files we've downloaded to which we've designated as our download directory. These would be our new downloads, ones that aren't registered in the history list. So in order to do that, a component, which is the criteria for a subprogram, is that it solves a component of the problem. It solves a subproblem. That component is being able to read a directory listing into a file, or be able to read a directory listing at all, because we can break that subprogram down into, or subproblem down into two subproblems. One is being able to get a directory listing, and the second one is writing the directory listing into a file list. Those are really two different subproblems. We could solve them at once, but if we want to really make sure things are debugged on a micro level, we could break those up. Well, the subprogram we want to write in order to test this capability, I called lister. And here once again it uses the system and the system IO namespaces, because the system IO namespace contains two classes we want to use. One is directory info, and the other one is file info, which here we're defining file info a couple different places. In the first place, we're saying an array of file info objects. So we have the square brackets after the file info to say this is going to be an array. And this is an excellent example of the way objects can be used to interact with each other. They're designed to interact with each other, really. So the first statement of this program, we say directory info di. We're instantiating an object named di that's of type directory info, or of the class directory info, equals new directory info, and then we're passing this the name of a directory, which is the download directory that has all the new download files in it. So we've established it's like an open text, but for a directory rather than a file. In effect, we've done an open on an object which we've instantiated of directory info type called di. And now what we want to do is get all the file names. Well, actually not all the file names. We want to get all the file names of type FLV, which are the type we're downloading. We might have a file and we don't want to know about them. You know, things like text files and whatnot. So we use a method of the directory info class, get files. And that says get all the file names that fit the pattern star, which is a wildcard matching any number of letters, or asterisk, .flv. And when you get those file names, put them into an array of type file info, which is a class we're instantiating an object, or an object that's an array named rg files. I paused for a moment to try and figure out why I used a Hungarian notation like RG. I could see FI, but RG, I don't know. That must have historical reasons from something else I wrote. So we now have an array called RG files that's filled with file names from the directories. That was pretty easy. It took 2 statements, and now we have all the file names we want from the file. And in order to look at those file names, I'm using a variation on a for loop called for each, which is kind of a nice thing if you want to iterate through an array of objects, because for each essentially takes a parameter that's of the type you want to iterate through. So we're creating a temporary variable called fi, which is instantiated of file info type, the same type as our array. And then we're saying for each member in this array, that's what the end says, in the array named RG files, put that into the fi variable that is also of the same type. They have to be of the same type because you're reading array members in of a certain type. And it's saying do this for each one until you run out of them. So essentially it has a built-in test that says when you come to the end of the array, stop the loop. And then all we're doing within the loop is a console write line of fi.name, and name is a property of an object of file info type. So name actually contains the file name of what was read in. So essentially this loops through and prints the name of every file in that directory. Also a very succinct way of doing something. Essentially one write and one loop defined with practically nothing there, but very effective. So if we compile and run this program using the techniques I showed you the last time, wow, we see there's nothing there. There's nothing in that directory. So while we were paused, I copied a bunch of files over to that directory. Guess I haven't downloaded anything there in a while. And one thing we want to do, especially for the sake of testing our final program, is make sure the files I copied over there are different from the files that are already in our history listing file. So I think you can see the history listing file pretty well because I'm using big print. But why don't I expand out some of these files that I have by actually looking at the file with Explorer, and you can see the names here are all pretty different from the names over in the regular window. There's nothing. The first one is how, so anything with a pound is going to be put before that. And the next one starts with an M, and if we go down and look at the M's, there's no names like that in our current history file. So this should represent a good test. So if we go back to the scene of our previous disaster here, this is where I did the lister, which ran our subproblem program that just prints out a listing of what's in that directory. And a way I can just bring that back up again is I press the up arrow on the keyboard, and that'll just put at the cursor whatever it was last typed in, which is also is a big time saver. It's not too bad when you only have 8 characters, but when you have a ton of characters, it's very nice. So I hit that again, and now I press enter, And now indeed we see a directory listing of everything that's on that file. Starting with the # file we saw, and then all the M files, which are MLM frustration, multi-level marketing. These are all by the same guy. I think his name is David. It was interesting. I haven't watched most of them, but soon. And so this subprogram works great. It accomplishes solving the subproblem we wanted to see we can accomplish. It's debugged. We know it works. So if we look back at our things to do list for the subproblem program 4, we've pretty much accomplished everything. We've gotten a list of file names and we've displayed it on the console DOS box to demonstrate to ourselves that it's working. And in the process of doing that, we've also gotten rid of, or we've also explained how the directory info class, the file info class, and the for each loop structure control work. And if you're having trouble remembering things, remember you can always go back and replay these. You don't have to get it all the first time. This is a really long lesson, so I'm expecting a fair amount of replaying to be going on. So the next subprogram we want to look at is reading the list of file names that we've gotten from the directory into an array list. Alright, for the next subprogram, or subproblem solving program, which I call lister to array list, one thing you'll notice is we added back the system.collections before it was commented out. And the reason for this is, once again, we want to bring back our friend the array list, still called myAL, probably because a lot of this code is just cut and pasted out of previous subprogram. So essentially this does everything we talked about before. It opens a text file that has the history file in it. Oh, that's interesting. Am I doing anything with that? No, I don't think so. I actually don't need this line. I should probably take that out. That should carry over to what our next program will be. Do a save of the modified program. We create the array list, then we do our directory info the way we did before. And once again we go through in a for each loop and we add all the names from the directory into the array list. But this time we print out the array list rather than printing out the file names directly in the loop. So the for each loop now just adds to the array list, and then we have a for loop that uses the count property of array list to determine when to stop looping, and loops through each of the indexes, the ix value, and the myAL square bracket, ix square bracket, and the printout. So we're looping through each of the members of the array list and printing it out on the screen. So it'll look the same as the previous one, and that it's printing out all the file names from the directory, but in this case it's reading them all into an array list, and then it's printing out the array list, which proves that the code actually fills in the array list the way we want it to. Now we're back in our DOS box. We compile this program, and it compiled all right. And now we do the run trick by doing a right click to bring it in the clipboard and we hit enter, and there we see all the same file names we saw in last subprogram but we know from having looked at the code that it's not working the same way. It's actually filling up an array list and printing them out. So if we look again at our list of things to do, subprogram 5 reads a list of file names from a directory into an array list. I'm using AL as an abbreviation for array list. So we've done that. We can highlight that guy, go up and press the done button. So this has been a long row to hoe, but there's only one problem solving program left, and that's combining the two lists of file names we got from two different ways into a single and array list. And then obviously there'd be two steps past that. We'd have to sort that array list so that they're all in the correct alphabetical order, and we'd have to save it to a file, presumably the same file name as the original history file, since it's going to replace that history file. So essentially when we complete this next step, the program is more or less done. But there's some nice bells and whistles we want to add to it, which we'll get into in the next chapter. Well, this is the sixth and gratefully last of the 6 subprograms that are in this really long lesson. I thought it was best to put these all together because they really all belong together. You're essentially reading in the history file, you're reading in the file names from a directory, then you're doing both of those to an array list, and the final subprogram you're combining those two into the same array list. So we create our old friend the array list here, and this time we do the stream reader just like we did in the history file oriented programs, and we also do the directory info and the file info as we did in the reading the directory file names oriented programs. And first we have a loop that's identical to the loops we've already looked at that reads in the lines from the file of the history file using our stream reader object. And then we have the same loop that we had previously that reads in the file names, but now this loop follows the first loop. So what's happening here is the array list is getting filled with the names from the history file, and then that same array list, without the names being erased or anything, is being added to by the names from the directory. So we now have both names combined. One of the main things we wanted for our final proposal of the program, that we have both the names from the directory and the original names from the history file combined in one data structure. And then finally we just print out this data structure to show they're both there. And they won't be in the correct sorted order because they've just been appended. We read in the history file first, then we read in the directory names. So when we print it out, first there'll be the history file lines, then there'll be the directory names, and they won't be sorted. So one of the things we had in our original design ideas won't be there yet, but it's mostly there. As you can see, we're almost done in a sense. Alright, we've done a directory of the names of our C# files in this directory, and it's file and dir to AL. In other words, both the file names from the history and the directory file names, the same array list. So I've copied that into the clipboard, the name of that C# file, and I right click, and that puts it on my command line with the compiler. I press enter and it compiles. Thank God there's no errors the way things have been going. And now I right click again and I backspace to get rid of the .cs, So now we just have the .exe file name, and we run that. And as you can see, the names in the directory, as you recall, started with this # source ID equals FLV file. So that's where the directory file names start, right here. And if we move up above that, there's all our history file names, quite a few. So I'm not sure if you can see all these, but essentially it worked. We've got all the names from the history file followed by all the names from the directory, which start at the # source ID equals ASO.FLV. So everything from here down is all directly read off the directory via the directory info and file info data structures. Well, that pretty much completes it. We've finished the last item, combining the history list and the directory file names list into one array list, and the subproblem solving program number 6. So I'll highlight that and click the done. And that completes everything. It was an extremely long class, and you know, feel free to pause and stop and then restart wherever you want, and also to replay as many times as you want, because there's a lot of information in here and you're probably not going to pick it all up on the first pass. And also, as always, write these programs yourself. I'll probably have a directory where you can download the source code for these programs. But don't just download it and compile it, because that's another way of deluding yourself into thinking that you know how to do it. You know, the best way really to do it is to pause this program and type in the code when you see the program displayed on the screen. That way when you type it in, it goes through another sensory modality of remembering. And then do your own compiles and do your own runs, and you know, have your own directories with your own files on them to verify that this code is working. Don't take my word for it, whatever you do. My recommendation is don't take anyone's word for anything. Verify it yourself, and when you do it yourself, you know it. Well, thanks for your patience in such a long class. The next one will be considerably shorter. Until then, remember to focus and learn a lot.